Welcome and thanks for joining this tiny little webinar on Huawei All Flash. My name is Wolf-Karsten Heintel, and as a solution manager in Huawei, I'm covering the topics storage and servers and convergence around that. Today I'm going to walk you through a couple of the challenges that enterprises of today are typically faced with and confronted with when it comes to adjust the best possible way in their IT infrastructure to the business needs that keep on becoming more and more rigid in both terms of efficiency, performance, and also in terms of reliability and high availability. And from that on, I will answer the question whether or not we have already entered the era of the all-flash data center. And then I'm going to introduce to you the newest member of the Huawei Ocean Store Dorado family to come up with a concrete solution to potentially go for in the future. Let's jump right into it. Let's talk about a couple of the typical challenges and demands that IT deciders and business owners in today's enterprises are confronted with. These demands are not necessarily new, but we can come up with new answers to these questions. Basically, it's all about the application. Well, talking IT infrastructure does not mean infrastructure does serve for itself. What is it there for? It's there for serving our customers. So it's about user experience. So, and how does Flash help in improving the user experience? So, and then whether or not a user experience is positive is dependent a lot on performance. So we're talking latency and IOPS, and this is what I meant by the application-centric approach. So we need to come up with a solution that serves our customers best. Then the second aspect is not only how quickly the systems need to respond to requests, it's also about high availability. So whenever I get to the enterprise, my data services have to be as reliable, as endurant, and as highly available as possible. So we're talking 24/7 business with almost no downtimes across the board. And the third aspect is actually the aforementioned efficiency in terms of cost and in terms of also footprint, like in a TCO perspective. So what does my platform cost me in terms of things like rack space, power and cooling, and also administrational costs. So while we are continuing on consolidating more and more workloads to these all-flash platforms, does that mean that the all-flash data center era has already begun, or is that yet to come? Well, actually, from my perspective and from the perspective of Huawei as a vendor that's strong in the all-flash area, we think that the all-flash data center is already here. Why is that the case? As you can see on that slide, the market proves that the all-flash era has already begun, because already in 2015, the actual revenues that have been generated globally in flash have overtaken those of rotating spindle. And also in terms of the shipment count, so how many units are going to be bought and purchased worldwide, we're going to overtake rotating spindle yet this year. So this kind of proves that the market has adopted flash and has understood that we're finally right on the brink of the true all-flash data center and get rid of all of that rotating stuff. So, and whenever it comes to the decision to go for an all-flash solution nowadays, we're typically talking about the tier 0 and tier 1 workloads. But as time goes by and as also the price digression that we see in flash continues on to drop in flash per gigabyte. So I'm not talking performance right now, I'm talking actual cost and capex, so initial investment in flash per gigabyte continues on dropping, and at one time soon crossing the price line that a 10K SAS drive has today. We will see an ongoing workload consolidation. So more and more of these tiers are going to become suitable for being hosted on a flash solution. By now, we figured that flash is the answer to a lot of the questions that are currently posed to IT deciders. But in order to come up with a better understanding of what a current all-flash solution today needs to address in terms of requirements and in terms of answers to provide, we need to have a look at the evolution of flash, how it came around, how it started, and how it started to step into the enterprise. So in the early days, back in like 2005, so 12 years ago, once the price point per gigabyte reached regions that were, at least for some application niches, suitable to go for flash instead of rotating spindle, guys like Violin came around, or Texas Memory Systems. They built systems that were incredibly fast and incredibly responsive to transaction loads, but these systems also had a tendency to be very, very expensive in the first place. And also they were suffering from a lack of features across the board. Though they were almost featureless, you can say. I'd like to call that JBOFs, right? Just a bunch of flash with no data services in terms of replication, be it local or be it remotely. No encryption available, no QoS, just nothing. Just serving the performance needs that applications needed to provide. And then the usual suspects started to notice that the flash train had begun to roll. And they were asking the question, well, how the heck do we come up with a solution that answers these questions to get a piece of that cake too? Because they were noticing that that might be the future. So they kind of took their existing legacy platforms that were originally invented and built for the rotating spindle as the data endpoint. And it happened around for potentially like more than 20 years already at that point in time. And they just kicked out all of the rotating stuff and all of the spinning rust and replaced these drives by flash modules. Around 2008, they kind of grabbed their existing platforms and bolted on that flash layer, but without any real optimizations in terms of how the media is actually treated. Because flash as a media wants to be totally differently treated as a rotating spindle wants to be treated. So they, in that short time that they had, they didn't have any means to address these implying requirements that come with flash. And then that's what we call a Gen 2 flash array. So it's actually a hybrid array that kind of claims to be an all-flash array just because there's no rotating spindle in it. And then over time, on these legacy platforms, acting as if they were an all-flash array, they kind of matured the system in terms of the way they treated the flash. So this comes in a lot of flavors like optimizing garbage collection, drop-down write amplification in order to extend the lifetime of the flash media, come up with deduplication and compression features that mostly are going to be a post-process thing in the legacy hybrid world. But that's then Gen 3. So the Gen 4 AFA, as we call it, comes in a fashion that they are not only fast and efficient in terms of data reduction to get down write amplification, so the write load to the flash media, but also they come with means to address these high availability requirements that I was mentioning before. So the more mission critical my workload is, the more the more rigid SLAs I have in terms of the number of nines that I'm going to be urged to provide. And then, a couple of startups came around, coming up with solutions that were really originally built for and optimized for flash. So what happened in Generation 4? Well, the incumbent vendors that previously offered all-flash solutions based on the legacy tiering platforms, they were acquiring companies. Like EMC acquired Extreme.io. Over time, the other vendors acquired companies like SolidFire, that's now with NetApp. Also IBM acquired TMS, so Texas Memory System, which is now IBM Flash System. Just quite recently, HPE acquired Nimble. And we as Huawei, we didn't have to acquire anything. We only started doing storage in 2008. And from that point on, we were already talking about a price point in Flash that made it quite apparent that we needed to go for like a dual approach. So we were developing our Ocean Store OS both for the hybrid world, so to come up with a solution based on rotating spindle with a Flash layer on top of that and the tiering algorithm in between the layers. And at the same time, we developed from the beginning a independent series based on the same operating system that's gonna be a true all-flash solution called Dorado. What's the conclusion of that? In generation 4, we need to come up with all-flash solutions that kind of comprehend it all. So not only be fast and responsive and provide the performance, but also provide at the same time the comprehensive feature set that an enterprise needs in terms of high availability. And while doing all that, we need to come up with a good price point to be efficient from a commercial perspective. So that's just the 3 pillars that I was mentioning up front, and I'm going to come back to them now and talk about performance, robustness and reliability, and also efficiency. So how do we as Huawei approach and achieve these goals that on the top of your head might be conflicting, like providing both the performance and the enterprise feature richness and comprehensiveness of data services for enterprise and high availability means? Is everything about software? Well, partially yes. The operating system that's going to be the base on which we deliver all of the features must be accompanied by hardware solutions that kind of provide the same levels of robustness, of fault tolerance, of individual aspects like heat dissipation, or also efficiency in terms of how can I scale. So scaling can be done in a lot of dimensions. You can scale capacity-wise, you can scale in rough or very fine granular increments, and you can scale, or you can have to address the need for scaling performance-wise by adding compute horsepower, or you scale connectivity-wise in terms of the number of ports you got to the front end. So in all of these aspects, we need to be flexible and agile, and this is a matter of hardware. So, and we as Huawei, we not only provide the software with all of the features, we're also a hardware manufacturer. So we got it both, and that's where the best of both worlds come together. So talking the NVMe stuff, I'm gonna get into more detail later. So because there's a lot of aspects that go along NVMe and the optimization potential that comes with it. For now, I'm gonna stick with the 3 main pillars and kind of clusters of features that our all-flash platform delivers. And I was mentioning it up front, it's all about speed and performance. It's, on the other hand, all about high availability, and it's also about efficiency. In a fully blown scale-out cluster out of 8 so-called engines, each engine has dual controllers, so 16 controllers in total, we are able to come up with an SPC1 IOPS count of 4 million, which is unique in the industry. And not only the IOPS is impressive, we are also able to sustain a response time given these workloads of half a millisecond. So this is probably the first array in the industry that addresses the tier 0 performance requirements best and is even able to come up with guarantees when it comes to IOPS at a given latency SLA. Talking high availability, Dorado is going to be the first true native all-flash array, so Gen 4 AFA, that's going to offer an active-active mirroring solution across data centers with a transparent failover. So what I was mentioning in terms of geo-redundancy, all of the other true AFAs, Gen 4 AFAs that are in the market space right now are not able to provide this feature. And then talking efficiency, through inline data reduction, so by compression and deduplication, and I'm saying inline, so that's happening in real time, not after the data have been written once to the media, but while the I/O is happening. We are able to come up with a guarantee of 3x ratio given certain application workloads. Of course, we will have to talk about the application mix that's going to be hosted on the array with the customer, And for these applications that kind of fit into this pattern, like small block random I/O, database workload schemes, and also everything which is virtual. So in the virtual server world, based on VMware, Hyper-V, KVM, and you name it. And also in desktop virtualization. So for all of these workloads, we are able to come up with an automatic guarantee that a customer is going to get a 3x data reduction. Basically, in practice, you are very likely to get even higher data reduction rates given the right workload mix. But we are upfront offering a guarantee of 3x for these workloads, which is also unique in the industry. Let me dig a little bit deeper in all of these three aspects that Dorado is offering. First, performance. The SPC1 benchmark, and you see the graph here, that's the actual results. It's actually been published a couple days ago, so it's officially confirmed. It's not Huawei lab testing and just claiming we can do it. We already delivered the proof that we can. So, and what you see here is the results in SPC1 for a scale-out cluster made out of a dual engine cluster. So a dual engine means 4 controllers. 4 controllers are able to deliver a little bit more than 1 million SPC1 IOPS. And if you scale that out to a fully blown cluster with 16 controllers, you can multiply that by 4. That's how I get to these 4 million IOPS before. So given these results, how do we compare to other major players in the AFA market space? Like on that slide, you see the 2 major opponents that we're facing. The market leader from a footprint perspective is currently Extreme.io from EMC, and also Pure Storage. They also publish performance numbers, but it's not officially proven. It's just from their lab testing, and well, they yet need to deliver the proof in a real world workload, so in actual customer scenarios, that these claims are really fulfillable. So I mentioned before that we are able to achieve 4 million IOPS with a Dorado scale-out cluster at a given latency of 500 microseconds. So what does that account for? Here you can see a couple of examples that have already deployed Dorado and how it helped their businesses. So how does Huawei manage to achieve these sustainable response times at given massive IOPS loads? Well, I must come back to the point that I already mentioned, that Huawei is not only a software vendor, but we're also a hardware manufacturer. So we not only offer a comprehensive feature set in terms of data services, we also have a very deep level of integration in terms of the components we leverage in our all-flash platform. So, and the fact that we as Huawei employ own technology end-to-end from the SSD across the controller to the array controller level implies a lot of potential to optimize I/O handling in general. We call that flash link. The SSDs Huawei manufactures are actually the fastest among the industry. So here you can see a comparison of the typical latencies per IOP that the various flavors of SSDs that are in the market typically deliver. So Huawei is number 1 in that space. To render it less abstract for you guys, so the actual HSSD 32 terabytes that you see on the slide, I brought one of these. We are actually going to support these in the Dorado series in 2018. You can see that here. It's 32 terabyte Huawei technology, homegrown SSD. And if I open that, in the drive, when I unfold that, you can see the 3D, in that case TLC NAND cells. And most importantly, I was mentioning that SSD controller that comes from the Huawei daughter HiSilicon. It's actually the same company that builds all of these mobile and tablet CPU and processors for us. So end-to-end homegrown technology, which enables us to do all of this sophisticated stuff. Just because a block that's going to be written to or read from an SSD has to traverse the SSD controller before it's going to reach the array level, it's important to mention that the SSD controller that's sitting on all of these individual SSD modules is also Huawei technology. So, and within that controller, there's a lot of features inside that enable us to optimize the I/O flow from and to the backend in a totally different manner than the competition can do. Among these unique features that we built into our SSD controller, to name just a few, is the intelligent CPU partitioning. So we are able to dedicate cores in our CPU in the controller to mission critical businesses, whereas other cores take care of the more general purpose workloads. And when it comes to data structures, like how do we allocate the individual blocks, both on the backend and in the cache, we leverage hash table instead of binary tree structures, which is like you step into a library seeking a particular book. So you have two options. Either you meet a library that's gonna be organized in shelves and you're looking for that one book, so you kind of refer to an index or a reference that is offered to you. And typically you're gonna be named a certain shelf where a book, depending on the category that you go for, is being located. And then within that shelf, it's going to be alphabetically sorted so you can easily find the book. And on the other hand, and that's for binary tree, you might step into that library and come across not shelves, no reference tables, but just a lot of bags where a lot of books are arbitrarily thrown into, and you seek these bags bag by bag serially until you find the book you were looking for. You can easily imagine that's going to take ages. So a hash table algorithm is much more efficient than a binary tree structure in that space. Part of the features that's going to be offered by the SSD controller is that we are going to be writing to the backend in full stripes. So we kind of write sequentially to the storage backend in order to avoid write amplification and to increase efficiency. And then last but not least, because we are able to talk bidirectionally end-to-end from the controller level to the SSDs and backwards, we are able to come up with a much better I/O prioritization in terms of what kind of I/O am I dealing with right now. Is that host I/O, or is that just garbage collection, or is that internal I/O? So we have a lot of more efficient means to optimize all of these aspects in comparison to the competition. Am I able to deliver the proof of everything what I just said? Well, to see is to believe, right? Until now, I was only talking theory, so why not have a look at an actual benchmark ran in our demo lab to give you an idea of what the performance looks like in an actual Dorado deployment.
Hello, this is Zhang Yi speaking. I'm from the Huawei storage production lines, and I'm in charge of the RD department of the Dorado production. Now beside me is the equipment of the Dorado 5000, and the location here is the open lab of the Huawei storage production line. And today I want to do some of the tests to evaluate the performance and the reliability of the Dorado 5000. Now first I want to introduce the environment of the test. Okay, let's have a look inside the test environment. We can see that we have two Dorado 5000 here. The reason why we deployed two Dorado 5000 here is that I deployed a hypermetro environment, but today I just want to test the one engine performance and the reliability. Let's have a look at the Dorado 5000. It's a 2U height and it can support 25 NVMe SSD. Today I had deployed 25 SSD, the full enclosure inside the engine itself. Each of the SSD has a capacity 2 TB, so the total capacity is 50 TB. Okay, now I will show you we also have 5 servers. The server model is the Huawei RX series 1288. We have 5 servers here, and I had deployed the Oracle rack on 4 of the servers. Another one, I deployed the VMware virtual machine in it. The test tool, we use the Swim Bench, and the version of the test tool is the 2.5. Okay, let's begin our first test. I want to evaluate the performance under the OLTP scenario. I have deployed 20 LANs on this Dorado 5000 because I want to save more time. And each LAN has the effective capacity of 400 GB. So the total effective capacity is 8 TB. And I also opened the compression, the online compression functions. We know that the compression or the deduplication has negative influence on the performance. Now we will check what the performance will be on the Dorado 5000. We can have a look at the capacities of the LANs. We can see that almost 800 GB per LAN. And we have 4 Oracle servers. Okay, I have prepared the scripts of the host, 40 users, and the IP address. Okay. Let's run the swan bench now, step by step. And all the virtual machine, I will run the scripts one by one. Okay, we will check the configuration parameters one by one and run the scripts one by one. Client 2, okay, client 3. We can see that all the scripts on 4 clients are almost the same, has the same parameters. Number 4 client. It's okay. Okay, the client has running. Client 2 running. Client 3, okay. Client 4, okay. Now we log in the Ocean Store Device Manager of the Dorado 5000. Let's have a look at the performance. We can see here we have 4 nodes. On each node, the performance now is 40,000 IOPS, and the time delay is about 400 microseconds. Okay, because we have 4 nodes, so the total performance, the IOPS, might be 160,000. Let's go back to check the circumstances of the 4 clients. Okay, we can see the performance is okay. Let's do the second test. I want to show you the performance under the OLAP scenario. Let's begin. Now we use the select script to check the table which name is the customers, and we will see what happened. Here we can see the performance on the Dorado 5000. The IOPS is about 90,000 IOPS, and the time delay under 600 microseconds. Okay. Later, I will start the select script on all the 4 Oracle nodes. We will see what happened. Okay, we found that the IOPS of each node is about 70,000 K IOPS, and the total might be 300 K IOPS, and the time delay is under 1.5 milliseconds. Let's have a look at the Oracle Enterprise Manager, and we found out that the IOPS is about 320K IOPS. Well, we think that the snapshot is very important. But now in the market, we know that many of the production is now available on the market. When we do the snapshot option, and the performance will be influenced. So today, I will do the test to see what happens when we do the snapshot option on the Dorado 5000. Before we do the snapshot options, let's have a look at the OLTP performance now existing on the Dorado 5000. We can see that on each node of the Oracle rack, the performance is about 40,000. And the performance of the total engine is about 160,000 IOPS, and the time delay under 0.5 milliseconds. Now, we will choose all the lines to do the snapshot options. Okay, let's do the choose. Okay. Now, I have finished to do the snapshot on all the existing lines in the system. Okay, processing. Now, the operation has been done. Let's have a look at the device managers, and we can have a look at the performance of the Dorado 5000. We can see that the performance has no influence. Okay, let's go back. We do the delete of the snapshot. We see what happened. Let's do the selections. Okay. Delete the snapshot. Let's go back to the device manager. We will find out that the delete of the snapshot has no influence on the performance too.
So walking away from performance as the one and probably most important pillar of the aspects that a true enterprise all-flash array needs to cover, and moving to the second one, which is no less important nowadays, reliability, high availability, robustness. So on that slide you can see what it means to businesses if they suffer from downtimes. So I was talking mission critical workloads, and the guys you see on that slide, like Amazon and the like, they generate huge costs from the point in time on that an application suffers a downtime. So we need by all means to find solutions that render an always-on 24/7 business for this kind of workloads, because a second of downtime can cost a lot of dollars. How we manage to achieve the degree of robustness, stability, and high availability that we offer on Dorado. Another measurement criteria that is commonly used in the industry to determine how reliable and robust a medium is the so-called mean time between failure. You might have come across that term. And similar to the other slide where I was comparing typical response times among SSD media in the industry, Huawei comes up with SSDs that deliver a much higher mean time between failures, so a better robustness and thus better suitability for enterprise and typical life cycles of like 5 years for a given solution. And then getting back to the triple parity aspect that I was already mentioning, that we as just a couple of competitors are able to provide. Well, the bigger SSDs become, and you have probably noticed that the evolution in terms of packaging density in flash is ridiculous. So where you have like the largest NSS drives that you can leverage in a shared sign array right now is about a 10 terabyte capacity. We started with very, very small and tiny SSDs a couple of years back, but in the meantime, capacity-wise, we overtook NSS and SAS by far. So you can expect like a doubling in packaging density every like 6 to 9 months. And the fact that Huawei in Dorado will support the 32 terabyte SSD modules that you already saw on the last slides in the arrays just means that the rebuild times in the case of a failure become more and more significant again, just like from the older times in rotating spindles. I don't know whether you guys have ever come across the time it takes to rebuild a full 10 terabyte NSS drive can take a week. So with smaller SSDs, that was not an issue at all. But the bigger SSDs become, the more significant and relevant becomes the rebuild time again. And based on our RAID 2.0 plus approach that I was already briefly explaining, we can come up with vastly better rebuild times than the competition is able to do. So, and talking triple parity protection, so the simultaneous failure of 3 drives per given RAID group without impact to the business. You will see a demo in a short while after I was talking about mirroring. Talking rebuild times, just to give you guys an idea of the difference in a traditional RAID approach. The time that it takes to rebuild a terabyte of data from parity typically takes around 5 hours. Based on RAID 2.0 plus technology and in RAID TP with us, you're going to cut that down to just half an hour, so by a factor of 10. So, and you can easily do the math, what that means for a 32 terabyte SSD. So, high availability wise, let's now, on our hunt for the 6th 9 in HA, let's now leave data center 1 and span across the inner link to data center 2 and set up a remote mirror, synchronous and active-active, and transparent and failover. Huawei is going to be the first in the industry able to offer such kind of a feature on a true AFA. And I must emphasize that it's not only industry first, it's only coming, as we call it, gateway free. That means it's just a part of the operating system and you do not need to involve any additional infrastructure or any additional complexity, both in deployment and administration, just like in traditional solutions, like for instance Vplex or SVC or something server-defined or software-defined like Datacore and Falcon Store. It comes as part of the operating system. It's also just a single-shot license. We do not license capacity-wise, as all of the other guys do. So this is really, really a very neat feature that you can go for if you are to deploy an application that has an SLA of a recovery point and a recovery time of 0. So you literally get back to the last I/O because it's synchronously mirrored without any needs for manual intervention to kind of promote a secondary site to be primary and online. That's going to be automatically done. And the recovery time that you need to get back, depending on this, the failure scenario, is near 0, but you literally do not lose any data and you do not have the need for any administrative intervention in the disaster scenario. Okay, that was a lot of input again, theoretical input. Time for the next breakout session, the next demo. Let me introduce to you a kind of a dual demo now regarding our triple parity protection and also hypermetro. Have fun.
Let's test the reliability of the system and the circumstances we plot out any 3 of the SSD. have a look at the cabinet. It has 25 NVMe SSD in one enclosure, and we choose any three of the SSD blocks out of the system. Let's we find what will happen. Okay, the first one, which number? Okay, 7. Next, I like 15. The third, which one? Maybe 22. I like 22. Okay, let's have a look at the system, where the IOPS influence and where the business continue. Now, the 3 SSD has been out of the system. Let's have a look at the performance of the Dorado 5000. We can see that the IOPS is lower than the before we plug out the SSD. The IOPS is about at the 80,000 IOPS, and the time delay is about 1.5 milliseconds. Okay, let's wait for a while because the reconstruction process is running in the system. It might take several minutes to recover the performance. Okay, let's have a look at the device managers. We can see that the IOPS climb up gradually and the time delay climb down gradually. Okay, now we found out that the performance of the Dorado 5000 is mainly about 80% of the topest performance before, and the time latency is about 1.2 milliseconds. Just as we saw, the reconstruction of this engine has been finished. Now, I will do the final test. As we know, we have 2 engines, 2 Dorado 5000 here, and these 2 engines has a relationship of the hypermetro. Now, I want to cut down the power supply of this engine, and we will see what happened. Okay, as you see, this engine has been powered off, and we will show the hypermetro, how the hypermetro works. Let's have a look at the Oracle Enterprise Manager. We can find out that the IOPS still continue. Okay, let's have a look at the device managers and Dorado 5000 system. We can find out that the IOPS continue too. The hypermetro solutions seems to work good.
Now I'm going to get to the last pillar of aspects that an AFA needs to cover today. Coming from performance and high availability, I now switch to efficiency. Efficiency both in terms of actual effective storage capacity to the server by means like inline deduplication, inline compression and other features, and also cost-wise. So while talking efficiency, first and foremost to be mentioned has, you guessed it, inline data reduction. Inline data reduction by compression and deduplication. That's not new. I mean, all of these native AFAs do it more or less well with more or less efficient reduction ratios given a certain application workload and workload mix that's going to be hosted on the array, because we all know the reducibility of data is 100% dependent on the data mix. So if we want to come up with a proper and reliable projection, so looking into the future of how efficiently are we going to be able to reduce a particular customer's data, we need to talk to this customer and to analyze what application mix he's willing to be hosting on that particular array. The typical data reductions for given applications that you see in the field, I'm going to talk about in a minute. But a differentiator between Huawei as all-flash provider from the competition is that we are able to come up with guarantees upfront for a certain application mix. So given a customer is planning on going for an entirely virtualized environment like in VDI or server virtualization, and or for everything which has to do with online transactions like database, OLTP, and also OLAP, data mining kind of stuff workloads. So typically random I/O with a certain read-write mix, we are able to provide that guarantee of a 3x data reduction. And this is an automatic thing that a customer gets when he goes for Dorado. So for a variety of typical applications in customers, we can come up with data reduction rates of far beyond 3x. That's why it's so easy for us to be confident to actually achieve these numbers. So the nature of this taking off risk from customers is that if we, for some reason, manage to deliver the promised capacity up front, it's up to us to amend and to commercially compensate the customer or to get down in price. Okay, so what does efficiency render at the end of the day? Well, it renders savings, both dollar savings, so commercially, and also space savings, and especially if you analyze that from the TCO, the total cost of ownership perspective, you manage to generate huge savings across the life cycle of the solution. And what I have here is a comparison between a traditional hybrid approach based on OceanStor 6800, so our classical hybrid series, compared to what the same capacity and the deployment based on Dorado is able to achieve in terms of savings in the various disciplines here. So you can see that even from a CapEx perspective, so the initial investment, the initial cost per gigabyte, we are almost at the same level than in traditional storage. But then when you expand this analysis to the operational costs, so the OpEx aspect of it, so management, footprint and rack space, and power consumption for operation and cooling, you see a vast potential in actually generate huge amounts of money in savings across the typical life cycle of, let's say, 5 years. And to talk about some other aspects in which efficiency and flexibility comes into place, I'm going to get back to the mirroring thing. So you have already seen a similar slide here when we were talking about the active-active gateway-free mirroring solution. We are not only able to synchronously and transparently mirror between data center locations with the same platforms, so from Dorado to Dorado, we are also able to incorporate the entire family of OceanStor converged in order to be mirrored to and from. And we are also able to mirror to and from third-party vendors, which accounts for a huge potential in investment protection for your existing gear. And also in terms of migration, it leverages the opportunity to almost entirely non-disruptively migrate from your legacy storage to Dorado. All right, then let's talk about compatibility or interoperability to your existing environment. So on that slide, you can see the entire stack of the ecosystem that we support with our Dorado platform. So ranging from the applications across the physical operating systems, the various hypervisors that are around, and also network layer like the Brocade, Emulex, and QLogic and Cisco's of this world. We're of course supported here. And also from the standpoint of this third-party involvement that we can manage to offer when it comes to migration and mirroring replication, that we support third-party vendors here with their systems. We support kind of anything that you might have seen in the market yet. So from all of the incumbent vendors, we are able to migrate data off towards Huawei OceanStor, Dorado, and we are also able to replicate to and from these vendors' platforms. Another aspect where efficiency comes into play is administration. So Dorado comes with a very intuitive and simple to use graphical user interface. Of course, we got everything else around that, like SSH, CLI, Open REST API, etc. But for basic administration tasks, you can just leverage the interface you know from Ocean Store Converged Classic series. It's very, very simple to use, and the efforts to get used to that are almost neglectable. So Huawei will come up with a comprehensive solution set for NVMe end-to-end from the server across the network to the storage to get the full benefit here. So there's going to be host bus adapters for NVMe and also means to incorporate NVMe over Fabric or NOF for stacking enclosures capacity-wise, so adding expansion shelves to a Dorado 5000, which involves an NVMe over Fabric technology. And on the right-hand side, you can see the Dorado 6K based on traditional SAS protocol. And the numbers you see here are typical performance and data reduction numbers and capacity figures that we are able to come up with guarantees given a certain scale-out deployment. All right. That takes me to the end. If you're interested in the entire Huawei enterprise portfolio, I recommend to drop by at http://e.huawei.com for further information about our portfolio. So that was it. Thanks for your time and hope I'm going to see you soon in your data center. Bye bye. Take care.